Hey guys, this is your video Edpuzzle here on simulations and models. So this is going to be a 2-day lesson. It's very short on the number of slides, so make sure you hang on tight. We're going to go through the stuff that we need to and get ourselves into Snap. So let us get going. Alright, so simulations and models. So simulations are computer representations of real life things or situations that vary over time. Simulations are abstractions designed for a particular purpose. Models represent things that can aid in defining, analyzing, and communicating a set of concepts. Alright, so why are simulations and models useful? So simulations and models help prove or test different things in a safe and cost-effective way. Consider testing safety features on car simulations. And these are essential in case of feature failure. So if you look at the little GIF to the side here, like a ejecting car seat, seems like a great idea. But in practice, maybe not so much based on this over-the-top little simulation that you see in the video. So simulations allow us to test certain things ethically. If you wanted to determine how quickly a disease spread, you would never test it on actual subjects because that is unethical. We kind of get by with that with animal testing, which again has its own ethical dilemmas with it. But again, we've, as a society, pretty much normally deemed that human testing is always unethical. All right, issues with simulations. So simulations rarely capture the full complexity of real situations. Computer simulations can simulate events using thousands of pieces of data, but may still be inadequate to represent a real event. So, event through simulations aren't perfect, but they are essential and viable in testing different situations. So, we know there's flaws in it, but it's better than nothing in cases where we're unable to test something due to ethical parameters. All right, so take a moment and answer this question. Where might simulations be used? Name 2 to 3 examples of real-life phenomena where simulations or models might be used. So pause the video, answer this open-ended question. You can use the internet to help you come up with a list of them, but list 2 or 3 phenomena where simulations or models may be used. Alright, so there's several examples. I mean, there's many examples, but just going through a few, you could use astronomical models to help understand celestial events like solar eclipses. You could use it in engineering for automotive design to help test safety and efficiency of vehicles. Healthcare, you could use surgical training to help practice for complex surgical procedures, so like a virtual walkthrough of a surgery. Education, you could use historical simulations to understand the historical impact of events. So there's lots of different areas that this goes into. Alright, so let's get into programming here. So let's create some simple simulations in Snap. So we're going to make 2 different simulations. I'm going to walk you through the first one, and then you're going to take a moment and adapt the first program to make the second. So we're going to go through and make a program together on how you could simulate rolls of a die 50 times. All right, so let's take a moment, open a new program in Snap, and we'll get started here in just a moment. All right, so let me move this over here out of the way, and let's get started. So let's get a control block for when we click. Let's do something different. Let's do when spacebar is pressed. All right, so we want to roll it 50 times, but we don't want to have to keep track of it, so we're going to have it make us a list. So let's go and find our list. We'll take that, and we'll throw this over here, and we'll grab it in a second. And then we're going to do set a variable. So we need to make a variable. So we're talking about rolling a dice, so we'll just call it die rolls. Now we can get our set variable block, and we'll do set die rolls equal to our list, and we'll just take it away. Take that little option away. So what you should have is set die rolls to the list. So every time it gets a value from what we're going to add, it's going to add it to our list. So let me just click. So notice when you do that, it takes the one little variable spot and turns it into a list. All right, so how many times did it want us to repeat it? It wanted us to do this 50 times. So we're going to repeat 50 times. And for each of these, we're going to need to add it to the list. So if you can't remember what it's called, hey, we're putting this on a list, so we can just say add. So we're going to do add thing to list. All right. So this is just the list. So we're just going to take it and I'm going to put the variable that it's called, which is die rolls. So that's where it's going to add it to. And so we want to do this. Oops, sorry, we got this structured wrong. This needs to go in there. It needs to be like that. There we go. All right. So now we want to make this where it does something 50 times. So think of a dice. What's an operator that we've used before that would operate like rolling a dice, picking a number between 1 and 6? All right. So you should say random number. So we're going to pick a random number between a normal dice. We're not talking like a 20-sided die. We're just talking about 6 sides. All right, so let's go through it. Oops, sorry, that's not supposed to happen. Go away. All right, so let's go through this. So when spacebar is pressed, it's going to set die rolls to the list. Boom. So we're going to repeat this 50 times, and each time we're going to add a random number between 1 and 6 to die rolls. So let's slow this down so we can watch it happen. And spacebar. 1, 2, 3. Speed it up. Make it fast. Make it small. And it rolled the dice 50 times. All right, so take a moment and you guys change that simulation to how you can simulate rolls of a dice 15 times. And just for clarity's sake, notice this is one die 50 times. This is dice. So you're rolling 2 dice here and you're doing it 15 times. So pay attention to that as you are designing your procedure. All right, so let's code this real quick. All right, so we're going to keep both of our programs on the same thing here, on the same program, because you're going to turn these in today at the end of class. All right, so let's put our new control on here. We're going to use the key operator, and we're just going to say up arrow, just so we keep it different. All right, so just like last time, we're going to have to set these to a list, but we're going to need a different list because this time we're rolling 2 dice. So let's just keep it simple and descriptive. Pair dice rolls. All right, so just like last time, we're going to set pair of dice rolls to our list. And then we're going to go in and we're going to repeat it the number of times specified, which was 15. All right. So remember, we're rolling 2 dice. So just like last time, we're going to have to do something similar to this, but it's not going to go quite the same. All right, so we're rolling 2 die individually, so 2 dice. So we've got to put both of these as a program or as a variable. So we're going to call one die 1 and then die 2. All right, so we're going to set die 1 with the random number 1 to 6. We're going to do the same to die 2, but to make it simple, we're going to duplicate and just change it there, just to save us a little time. All right, so we're rolling 2 dice, so each time we're going to want to get the total between those 2 dice, so whatever die 1 and die 2 add to. So we're going to need another variable, and we're going to call this one dice total, because we want the total that the die add to. Sorry for my spelling there, guys. We don't have Microsoft Word or spell check in this. So dice total. All All right, so we're going to set dice total equal to die 1 plus die 2. So we're going to get the plus operator, and we're going to get die 1 and die 2. Notice how we're putting our variables in these operators to make it do the math for us. So it's going to use, I'm going to move this other one from the first program out of the way. All right. So notice it's going to keep die 1, die 2 separately here, and then it's going to add those two together to give us our dice total. This is going to make it do the whole thing for us. So let's wrap this up. All right, and our last step is to have it add it to the list. So we're going to do our add to list. All right, so if you don't know how to find it, I know where the color it is, but we can just type that to bring it up. It's going to go under. So we're going to do add dice total and add it to our list, which we called paired dice rolls. And we define that up there at the top. So when I press up arrow, it should run it. All right, so it rolled those sets of dice 15 times each. And that's our totals of the 2 die. Alright, so these were very simple, and these essentially were just used to create data sets of possibilities. So the only thing we used these 2 programs for was just to generate data for us. So let's move on to our assignment of the day, and you'll have some time to finish this tomorrow. And you guys are going to go through on a disease spread simulation. So on this, it will actually go through and walk you through the nuts and bolts of this assignment, which is an AP level assignment. So you're not expected to go through and use the links provided in the link that I'm going to send you in a moment with the worksheet. I'll send you a sample program that I'm specifically having you work with. But let's look at that. So this is the disease spread simulation. So let's watch it run. So every infected person that comes in contact with a healthy person will turn the healthy person into an infected person. So as it says, this isn't a COVID thing. This has been around longer than COVID. So this is just simulating how disease spread would happen if it's a contact virus. So that's the simulation. So that's what you guys are going to be working with today. So let's actually look up exactly what you guys are doing. So this is the program you guys get. So this, and this are all done correctly. What you guys have to do is take a moment and think through the instructions once you read through them, and I'll give you a separate link to that in a moment. But your job is going to be to figure out how this goes inside the warp spot. And so on the warp thing, this just simply makes everything inside of it go very fast so that everything runs smoothly. So how you noticed all the little people move smoothly in the video you watched previously, the warp function allows that. So read through the instructions and figure out how you set these together to actually come up with your completed program that you guys are going to make. So everything you need is right here in this area. So you just have to put it together and it goes inside the warp blank, and then you're able to just run the program. So take a few minutes and go through and try to solve this, and we will go over this tomorrow before we actually get into your project where you are going to be making your program in Snap that you designed with your user interface with selling ice cream. And just to circle back, make sure you have your submission done for the day. The only thing you need to submit is on 10.1b. You need to submit your completed Snap program where we went through and did our 2 programs here. So this is what you're submitting in Snap. Keep it simple. Just name it literally. You can call it 10.1 this, or you can call it the DICE program. All right, so make sure you have your submissions done for the day, guys. If you got questions, let me know.